what are the methods by which we will represent a set? We can represent a set. So to represent a set, there are two methods. The first one is a tabular form, and the second one is a set builder form. The tabular form you can also name it as a roster form and the set builder form. Now today we will discuss some definitions on set theory. So here some important definitions. So our first definition is an empty set. Now if I say empty set, what do you mean by empty set? It is very simple. The name itself gives you the idea about that particular set. So what is an empty set? Empty means
Empty means
nothing. If I say okay, this
nothing.
is an empty glass, that means the glass has nothing in it. So similarly, in a set also you can say that suppose empty set means in that particular set there are no elements. So let's start with that, but with one example. Okay. Now here see, I have given one example that capital A is equals to X, such that X is a student of a postgraduate recently studying in a school. Now, what do you mean by this particular statement that X is a student of a post graduation who is presently studying in a school? So, do you get any student of a post graduation who is studying in a school? Will you get any student? Post graduation means a student of a master degree studying in a school. Any master degree student will study in a school?
No.
No. That means for this particular set, you will not get any member. So here she is thinking, okay, any master degree student studying in a school, so she is not getting any student. So the this particular example will not have any members. Okay, so this is an example of an empty set. Okay, any set which does not contain any element or any member is known as an empty set. Now, can any one of you give me another example of an empty set? Any one of you? Any one of you? Can you give me one example of an empty set? Hello? Yes, try to give one example. There are so many examples of empty set. It is not necessary that all the sets are from your number theory. You can give your any day-to-day example of an empty set. Hello? So you can tell that okay, a boy studying in a girls' school. Do you get any boy in a girls' school? Will you get any boy? That means a boy studying in a girls' school. Will you get any student?
No, no.
No, so that means it is an empty set. So in this way you can give you will have so many examples of an empty set. Okay, so okay, one more example is I can give you that any girl student studying in a boys school, again it is an empty set. So these examples are from your day-to-day life. So that's why we can say the definition of an empty set, we will write it as a set which does not contain any element is called the empty set or the null set or the void set. That means you will have three different names for this particular set, empty set. Sometimes it is called as an empty set, or some may call it as a null set, or sometimes it is known as a void set. That means these three names will represent the same particular set. The empty set means a set which does not contain any element. Okay. So are you clear? All of you clear about the empty set? Okay. Next example is a singleton set. Now, singleton set. Singleton means single means what? If it's a single means what do you mean by single?
Person, ma'am.
Yes, single means
One person is standing at the door.
one person standing at a door. Okay, this is an example of a singleton set. That means if you have an idea that a singleton set means a set containing only one element. Okay. Now I can give you one example. Example of a singleton set is like the lady president of India. So how many lady president we are having? How many lady presidents? Only one, that is the Pratibha Patil. So that's why it is a singleton set. So in this way you can give other examples of a singleton set also. So here the singleton set, the I can say the set of an even prime number. Now the set of even prime numbers contain how many elements? What is the even prime number? A number.
Two.
Yes. So in this particular set, we will have only one element, that is number 2. So here 2 is the only even prime number, and this particular set we will represent as curly bracket and 2. Within this curly bracket we will write 2. So we will have only one element. So that's why it is a singleton set. So we will write a definition of singleton set as a set containing only one element is known as a singleton set. Okay. So till now we have done two definitions. First one is an empty set and the second one is a singleton set. Now next definition is the finite and the infinite sets. Now these two words, finite and infinite. What do you mean by finite? If I say finite, finite means what? Finite means Finite means you can say in a simple word, simple language, that finite means you can count. That means you can count the numbers. Okay, these are known as a finite set. Now, if I say infinite means it is count. Okay, so the in set also the meaning of a finite and infinite sets are same. So if I give you the example of the set containing the elements 1, 2 and 3. So in this particular set, how many elements are there? In this particular set, how many elements are there? There are 3 elements, 1, 2 and 3. So there are 3 elements in this particular set. Again, if I give you the example of the set of vowels of English alphabet. Now tell me how many elements will be there in the second set, vowels of English alphabet. How many elements?
Five.
5 elements. So there are 5 elements in the second set. So now see the first set, it has 3 elements. Second set, it has 5 elements. So these 3 and 5 are finite numbers. Okay, why these are finite numbers? Because you can count 3 and 5, so that's why they are finite numbers. And the set with finite number of elements, we call it as a finite set. That means if a set has finite number of elements, that set is known as a finite set. Okay, that means the members you can count, those sets are known as a finite set. Next, if I tell you the set of natural numbers. Now, any one of you can you tell me the total number of elements in the set of natural numbers? Hello? The set of natural numbers means numbers from numbers from 1 to set of natural numbers 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10. All these numbers are known as natural numbers. So how many natural numbers we will have? We will have how many natural numbers? Can you count all the natural numbers? Okay, we can count from 1 to 100. Okay, then after 100 we will have 101, 102, 103 and so on. Next we will have, suppose we have counted up to 1000. Then again you have one more number, the 1001, 1002. Okay. So that means you can say the set of natural numbers are infinite, because there are so many natural numbers and you cannot count all the natural numbers. That means you cannot count up to the last number, last natural numbers. So this set of natural numbers is infinite. That means they have infinite members or infinite elements. So the infinite set, we will define the infinite set as with infinite number of elements. So I will write the definition of infinite set like, if the set with infinite number of elements are known as an infinite set. Okay, so give me one example of an infinite set. Any one of you can give me one example of infinite set other than the set of natural numbers. Other than the set of natural numbers, any example of an infinite set? You can you can say that the set of a whole numbers is an infinite set, because whole number is starting from 1, 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on. So the set of whole numbers is also an infinite set. Okay. Now, next definition is our equal sets. Now, for equal sets, always remember we need at least two sets. Okay, then only we can define equal sets. Now, let's see. There is a set A and the elements of a set A are 1, 2, 3 and 4. Next, you have another set capital B with the elements 3, 1, 4, 2. Okay. Now see the elements of set A and set B. Set A, the elements are 1, 2, 3, 4, and in set B, the elements are 3, 1, 4, 2. Okay. Now, in set A, how many elements are there? There are 4 elements. And in set B, you will have how many elements? Again, in set B, how many elements are there?
Four.
4. So, set B also 4 elements and the elements are 3, 1, 4, 2. Now compare the elements of set A and set B. What can you say about the elements of set A and set B? They are same elements. Yes, because see in set A also you have 1, 2, 3, 4, and set B also 3, 1, 4, 2. That means okay the elements are same but their positions may not be same. It's okay. But the numbers are same. So that's why you can say that set A and set B has the same number of elements. That means both the sets has 4 elements and the same elements because they both the set has the elements 1, 2, 3 and 4. Okay. So the equal set will define the equal set like this. Two sets capital A and capital B are said to be equal if they have exactly the same elements, and we will write for equal set capital A is equals to capital B. Okay. So always remember if you have two sets capital A and capital B, then both the sets will be equal to each other only if they have same number of elements, also the same elements. Okay. For example, suppose you have a set A whose elements are 1, comma 2, comma 3. So set A has 3 elements. Again you have another set B, and B has the element A, B and C. Okay. Now B has 3 elements. Again set A has 3 elements. Now can you tell me whether capital A is equals to capital B? Can you say capital A is equals to capital B? Because both of them have same number of elements.
Not equal to.
Not equal. Why they are not equal?
Uh, it's not same number are not same.
Yes, because yes, they have the same number of elements, that is 3. Both of them have 3 elements,
Okay.
but the
But
second
the
point
element
is yes, the elements are not same. So that's why capital A is not equals to capital B. Okay. So this is all about the equal sets. So for equal set, you have to check for 2 points. First one, they must have equal number of elements, and the second one is second point you have to verify that they have the same elements. Okay. So the both the points they have to be fulfilled, then only you can say that capital A is equals to capital B. So next is the equivalent set, the definition of an equivalent set. So suppose you have a set capital A and whose elements are A, B and C, and you have another set capital B whose elements are 1, 2 and 3. Now tell me what do you notice from this set A and set B? What can you say about the set capital A and capital B?
Elements in both sets are different.
Yes, the elements are different, but what is common between capital A and capital B?
There are three numbers of
Yes,
elements.
they have same number of elements. So from capital A and capital B, you can say both of them has 3 elements, but the elements are not same. Okay, but they have 3 elements. So the equivalent set you can define as the sets with same number of elements. Okay, if two sets has the same number of elements, then the two sets are known as a equivalent set. So here always remember, in equivalent set, nothing is there about the elements. Only it is written that they must have the same number of elements. It is not necessary that the elements are same. The point is they must have same number of elements. So that's why we can say that capital A is equivalent to capital B because they have same number of elements. Now, you have just have the definition. You have just gone through the definition of equal sets and the equivalent set. Now, tell me the difference of equivalent set and equal set. What is the difference between equivalent set and equal sets?
In equal sets, the
Yes.
elements must be equal to.
Yes, in equal set, it has to be satisfied two conditions. So first one is they must have the equal number of elements, and next they must have the same elements. Okay, but in equivalent set, only one condition it has to be satisfied, and that is the same number of elements. But elements may not be same. So this is the difference between the equal set and the equivalent sets. And next definition is our universal set. Okay. Now for universal set, you need one more concept. Okay. So before going to universal set, let's see what do you mean by a subset. Okay. So I'm giving one example, like capital A is equals to 1, 2, 3 and up to 10. Okay, as said, capital A whose elements are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now you have another set capital B and whose elements are 1, 3, 5, 7, 9. Okay, now tell me about capital A and capital B. What do you notice from these two sets, capital A and capital B? Capital A has the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and capital B has the elements 1, 3, 5, 7, and 9. So from these two sets, we can say that the elements of a capital B are also the elements of capital A. Is it true? Is it true that
Yes.
all the elements of capital B are the elements of capital A also? But capital A has some extra elements, and those extra elements you can say the 2, 4, 6, 8 and 10. These are the extra elements of capital A other than capital B. Okay. So in this case, whenever all the elements of capital B are also the elements of capital A, and capital A has some extra elements, then we will write capital B a, is a subset of capital A. Okay, so B is a subset of capital A. That means B, capital A is the bigger set than capital B, where all the elements of capital B are in capital A. Okay, so this is simply you can have that concept of subset. Okay, so subset means if capital B is the smaller set, capital A is the bigger set. Okay, so this is a simple way to remember what is a subset. Are all of you clear about subset? Are you clear?
Yes,
Yes,
ma'am.
ma'am.
Okay, so after subset, you will have a definition of a universal set. Now, universal set. If I say the word universe, what do you mean by universe? So simply universe, if I close my eyes and I will think about the word universe, then I have a picture like we are floating in that universe. In universe, there are so many planets and stars and everything is there in the universe. Okay, is it true that universe is a bigger space and we are within that universe? Simply in set theory also, the universal set has the same meaning. That means all the sets are there in that particular set, which is a bigger set. Okay. So the universal set, the definition is this is the set containing all the elements and of which all the other sets are subsets. That means the universal set is the biggest set and all the sets are subsets of the universal set. Okay. So always remember universal set is the bigger set and all the other sets are subsets. Okay. So are you clear about the universal set? Are you clear about the universal set?
Yes, ma'am.
Ma'am, can you give an example?
Yes, the example you can say that, okay, suppose I will write it here. Capital N, the set of natural numbers. Set of natural numbers. Okay. So the set of natural numbers, the elements are like 1, 2, 3, and so on. Okay, all the numbers. Then, if I consider capital, suppose capital E, and E is the set of even numbers, and the elements are 2, 4, 6, 8, and so on. Okay. Now, if I compare these two sets, capital N and capital E, then what can you say about capital N and capital E? You can say that every member of capital E is a subset, is a member of capital N, because capital N is the bigger set, capital E is the smaller set. Okay. Similarly, if I write O, the set of all odd numbers, the elements will be 1, 3, 5, and so on. Okay. Now see, capital E, the set of even numbers, and capital O, the set of odd numbers, are subsets of capital N. Is it true? So capital, in this case, capital N, we can say name capital N as the universal set, because the other sets like capital E and capital O are the subsets of a capital N, and capital N contains all the elements of capital E and capital O. Is it clear? Now is it clear?
Yes, ma'am.
Again, okay. Now I am adding one more set, which is the set of whole numbers, and the elements will be 1, 0, 1, 2, 3, and so on. Now tell me, which is the universal set? From these four sets, which one is the universal set?
W, ma'am.
W, because see, W has one more extra element, capital O, and all the sets N, E, and O are the members or are the subsets of W, that is the whole numbers. So in this case, if I consider these four sets, W is the universal set and N, E, O are the subsets. Okay. So now are you clear about the concept of a universal set? Are you clear?
Yes, ma'am. Yes,
Yes.
ma'am.
Okay, so this is about your definitions, some important definitions of a set theory. So next portion will be your subsets. Okay, subsets. See, in set theory, the definitions and examples are important, and next is the subset. Subset is a very important topic from your set theory. Okay, so today you will, after class, you will just go through this definitions, this example, and if you have any doubt, you can give me that question, or you have that doubt in our WhatsApp group. We will try to discuss. Okay. So here today I will stop here. So in the next class we will start the topic, the